Howdy. I haven't read this through yet, but I just wondered because I knew about this effect. If you take different sized pebbles in a bucket, and there's like smaller ones and bigger ones, and you shake it, after some time, the bigger ones are on top and the small ones are at the bottom. Like, somehow I think most people should know that. But anyway, this is a very interesting article because it triggered me to make a video. And probably will notice, no, you will notice because I will tell you where's the very interesting part of that. But anyway, nuts about science. The Brazil nut effect shakes up physics. University of Warsaw. April 23rd, 23. A bag of mixed nuts. After shaking, smaller nuts fill in the gaps created at the bottom, pushing the larger Brazil nuts to the top. Physicists from the University of Utrecht and the Faculty of Physics at the University of Warsaw have observed, for the first time experimentally, that Brazil nut effect in a mixture of charged colloidal particles. Until now, it was thought that an influx of external energy was required to create this effect, but the researchers were able to confirm that the process can occur spontaneously. The findings published in the Proceedings of the National Academy of Sciences, PNAS, could find applications in a wide range of fields from geology to soft matter physics. Yeah, geology. When you open a can of mixed nuts, it is common to give it a shake. Have you noticed that after such an action, the largest nuts in the mixture, Brazil nuts, float to the top? The phenomena of large objects rising to the surface of a mixture of small objects bearing the professional name of granular convection is popularly referred to the Brazil nut effect and occurs commonly in nature. It can also be observed by shaking, for example, a bucket of sand and pebbles. Yeah, it's funny also that it's around Brazil in some sense the South Atlantic magnetic anomaly. And we have Moomy socks. For those who don't know Moomy, check them out. They're very interesting. There's like I tried to make a video once about Moomy, but it got banned for whatever reasons. So I don't do Moomy videos anymore. This unusual fact contradicts the intuition that heavier objects should sink to the bottom due to gravity and inertial force. This is the case with the phenomena of sedimentation, common in nature, a process involving the sinking of solid particles dispersed in a liquid under the influence of gravity or inertial forces. Or maybe it's just the buoyancy. But anyway, sedimentation plays a role in processes such as the formation of sedimentary rocks and is also used to purify water and wastewater or isolate cells from blood. Yeah, maybe the sedimentation process happened rather quickly. Electrostatic stratification. Due to the charge of the environment, different charged particles get attracted to the ruling charge in the environment and they get depleted. And also, this is why we have layers of metal within mountains. Because of the magnetics. Brazil nut effect in charged colloids. Until now, it was thought an influx of external charge, such as shaking the bag. Yeah, external energy. Yeah, it's always energy, you know. You can measure it always in an electric way as well. Was necessary to create the Brazil nut effect. However, theoretical models being developed suggested that the phenomena could occur spontaneously without the supply of external energy. The theoretical calculations were confirmed experimentally for the first time by a group of experimental and theoretical physicists from the University of Utrecht and Faculty of Physics of the University of Warsaw. The result of the study appeared in a paper published in the journal The Proceedings of the National Academy of Sciences of the United States of America. We have shown that the Brazil nut effect can take place in a mixture of charged colloidal particles driven slowly by Brownian motion and, listen, repulsion of electric charges. For those who still live in the gravitational paradigm that the universe is governed by gravitation, I recommend you to listen to Wal Thornhill, for example, who's talking about how gravitational forces aren't forces themselves, they're just an effect of the electromagnetic force. Because the energy or force which attracts something is tied to the charge of the body itself. That's why, for example, we have it goes very well with those old tales where we had planetary discharge events. A planetary body, let's say Venus, came rather close to Earth, but it didn't slam into it because first it was attracted, but the electromagnetic force works as such that over long distances it works attractive, over short distances repulsive. So the energy which was created through the force of repulsion ended up being a huge interplanetary thunderbolt, for example. One example are the mountains we have on Earth, or the Grand Canyon. We have shown that the Brazil effect can take this, we have already read. Yeah, probably need to have new boots as well once then. Colloidal mixture. The researchers used charged polymethyl methachloride particles with different diameters, large and small, to carry out the experiment. A low polar solvent, cyclohexyl bromide, was used as a dispersing agent. As the researchers point out, although in both granular, e.g. nut, and colloidal mixtures the Brazil nut effect occurs, the mechanisms for its formations are completely different. In the case of a nut mixture, as a result of shaking smaller nuts, fill in the gaps created at the bottom, pushing the larger nuts on top. Meanwhile, the charged particles in the colloid make Brownian motion as a result of collisions with the surrounding solvent molecules. Each particle is positively charged, heavier, but larger particles have a greater charge. Heavier and larger planets have a greater charge. It's scalable. Electric universe, indeed. So they repel each other more strongly. Yeah, that's maybe the reason why the gas giants are so far away from the sun. And the small ones are much closer to the sun. Maybe. I think it could be very well possible. But anyway, the discovery of the Brazil nut effect in mixtures of colloidal particles can be used in many fields from geology to soft matter physics. Yeah, gas giant is rather soft. It can also find application in industry, such as in the stability of paint and ink. Yeah. Probably you need a lot of ink when you write all the physics books. Either new or you used ones which are actually true. Where no one is hunting for black holes or dark energy or dark matter or whatsoever strange stuff. Or cats. Schrödinger's cats stuff. Yeah, where's the article? Let's see if we have access. Just try for the science. Is it open access? This article has been updated. Get access. So I assume that if you are not part of the scientific community, purchase, subscribe, or recommend this article to your library. Yeah, maybe I have to try. But I wouldn't be surprised if this would be behind institutional walls. Something happened. Did I push something? We maybe went back to the article. Yes. No, it's about science. Yeah. Charged particles repel each other. Equally charged particles. If that's a planet, it's charged minusly on the outer side and plusly on the inner side. So they will repel each other. And there might be a lightning bolt between if they come too close to each other. Like as the ancient people are telling us. But anyway, thanks. Bye.